So lesson is getting recorded now, which is about the angles, converting between degrees and radians, finding coterminal angle, finding the length of a circular arc, and use linear and angular speed to describe motion on a circular path. So that's what we are doing. So first thing that you see is when we draw the angles, we start with a ray. So we're going to have a starting point and then a direction in which the ray will be going towards. The ray consists of one point on a line and all points extending in one direction from that point. Like this is called a ray EF. Okay. Angle is the union of two rays having a common endpoint. Endpoint is called the vertex of the angle, and the two rays are the sides of the angle. You will see in the pictures as I scroll down the page, a couple pictures about the angles and all that. So here is one of them. And there are various symbols people use to write the angle, and one of them is theta, phi, alpha, beta, and gamma. These are the common symbols that are used to write an angle. So scrolling more down to give you a visual of the angle theta, then your vertex, this side is called initial side, this is called the terminal side. And this is your standard position of the angle. So whenever you draw an angle, this is your x-axis, this is y-axis. The initial side is here, terminal side is right here. So this is 90-degree angle. When we complete one circle around the center, the origin, that is 360 degree. You see there is only one line, so initial side go overlap with the terminal side. Okay. So this is 0 degree, this is 90 degrees, this is 180-degree angle, this is 270, and then 360. And the numbers that you see written right here, they are called quadrants. This is the first quadrant, this is second quadrant, third quadrant, fourth quadrant. There are total 4 quadrants in your coordinate system. So there are the measures of 0, 90, 180, 270, and then 360. So drawing an angle in the standard position, here they're sketching 30 degrees and negative 135. So they're saying 30-degree divided by 360 is 1/12. It's going to be, if you cut the pizza in 12 slices, it's one of them. Okay. So then they're cutting that and indicating the 30-degree angle. Same way, if you have 135, that's negative 3/8, negative 3/8, then they're rearranging it 3/2 of 1/4. So if you have a quarter, quarter means the fourth part of the 4 sections. The 3/2 of that means 1.5 of that, halfway through that. And it's a negative side, so it's going to go it's going to go clockwise from here for the negative angles. Another important thing which I wanted to mention, that anytime a negative angle is given to you, like this one is, you go this way, you go clockwise direction. And when you're drawing normally, you go anti-clock. So if you're drawing 90-degree, you're going to be here, 120, and so on, and then 180, and then so on, 270, and then 360. That's the regular way of drawing it. But when you have negative angle, you go in opposite direction, which is clockwise direction. That's what is shown here in 135 degrees angle, the negative 135 degrees. Now, moving forward, converting between degrees and radians, there are 2 types of measures that we use for the angle. Like your circle circumference, you might have seen that formula C is equal to 2 pi r. So they're indicating that here to tell us that how the radians are calculated. So the 2 pi is equal to 360 degrees. When we complete one rotation, starting from the initial, we go around and we complete one rotation that's 360 degrees. And that is equivalent of 2 pi radians. 2 pi radians is equal to 360. If we divide by 2, pi radian is equal to 180. So you can simply keep in the mind that as you begin from here, you go around. This is pi, 180 degrees. And then if we wanted to tell somebody what is 1 radian, so that will be 180 over pi. Okay. So taking forward from here, this will be used in conversions of radian to degree and degree to radian. And this is the formula we will be using to find the arc length. S is equal to r theta. R stands for the, the length that's going to be in there. And theta is the angle spanned. Arc length S is the length of the curve along the arc, like this is with the orange, just as the full circumference of the circle always have a constant ratio to the radius. The arc length produced by any given angle also has a constant relation to the radius r. This ratio called radian measurements. So it's the same regardless of the radius of the circle. S is equal to r theta is the formula that we use in this one, and then we calculate according to the problems or questions, whatever angle is given to us. And couple more things that I wanted to bring to your mind. So we're going to be using radians, degrees, conversions, and this is called the unit circle, which I will introduce in the next section as well. These are the all major angles which are marked in the first quadrant: 30, 45, 60, 120, 135, 150, 210, 225, 240, 270, and so on, going back up there up to 360. That same unit circle is drawn in the radians. 30 degree is about pi over 6 radians. 45 degree is pi over 4 radians. 60 degrees pi over 3 radians. 90 degree pi over 2 radians. 180 full pi radians. 120 is 2 pi over 3. And wanted to tell you that how do they convert it from degree to radians. So all you do here is you take this, like suppose you are converting 30 degrees into the radians. You take that 30, and we saw earlier that 180 is equal to pi radians. 180 degrees is equal to pi radians. That's what I showed you in the definitions above. 180 is equal to pi. So if 180 degrees is equal to pi, that means 1 degree is equal to pi over 180. So when you're converting your 30 degrees to radians, you're going to multiply by pi over 180. That will give you 30 pi over 180. So 30 divided by 80 give you 1/6. 30 divided by 180 is 1/6. That's how you end up having pi over 6 for 30 degrees. Same way, you can also convert 45 degrees, and you take 45, multiply with pi over 180. And if you do it on the calculator or try to divide 180 with 45, you will get 1/4 here. So this will be pi over 4. That's how they get 45 as pi over 4 here. Degree to radian conversions. You can also convert radians back to degrees. So if I have pi over, um, so if I have pi over 3, which is 60 degrees, to see it in the degrees, all I will do is I will fill the pi as 180. 180 over 3 is 60. 2 pi over 3 Convert it back to degrees. Fill pi as 180. Divide by 3. 180 divided by 3 is 60. 2 times 60 is 120 degrees. So you can convert back and forth from degree to radian and radian to degrees in here. And we will do problems related to that in our exercise as well. Taking us forward here, finding a radian measure. This is saying find a radian measure of 1/3 of a full rotation. 1/3 of a full rotation. Full rotation is 2 pi. So it's 2 pi over 3, 1/3 of a full rotation. 2 pi over 3 because the full rotation is 2 pi radian. So 1/3 of the 2 pi. Then this is just the examples, like I shared some examples of radian to degree with you. They are sharing those examples here. This is important, understanding the co-terminal angles. Converting between radians and degrees can make working with angles easier in some application. So for other application, we may need another type of conversion. Negative angles and angles greater than full revolution are more awkward to work with than those in the range of 0 to 360. It would be convenient to replace those out of the range angles with a corresponding angle within the range of a single revolution. So what we're going to do here is we're going to be basically trying to calculate the co-terminal angles of a given angle. This paragraph is trying to explain to you or give an introduction of the coterminal angles. So I'm going to read it. It is possible for more than one angle to have same terminal side, as you see right here. So the terminal side of this angle, which started here, is 140 degrees, which goes this way, starting from this way. That's 140. But if you look at another angle, which is drawn here, this way, that also has a terminal side here. So they both are sharing the terminal sides. Okay. They're saying it is possible for more than one angle to have same terminal side. Look at this picture. The angle of 140 is a positive angle measured counterclockwise. The angle of 220 is a negative angle measured clockwise. But both angles have the same terminal side. Same terminal side. If two angles in standard position have the same terminal side, they are coterminal angles. They are called coterminal angle. Every angle greater than 360 or less than 0 degree is coterminal with an angle between 0 and 360. And it is often more convenient to find coterminal angles with the range of 0 to 360 than to work with an angle that is outside that range. Now, I'm going to take us down through some examples to help you understand this concept more deeply and retain that to your mind. So as you see right here, they have marked the quadrants. The quadrant 1 right here, quadrant 2 right here, the quadrant 3 and the quadrant 4. So for quadrant 1, they're saying your coterminal angle for quadrant 1 will be, so for example, you see right here, it goes this way. And they're saying T dash is equal to T. And here they're saying, okay, this is quadrant 2. Here is the angle, this one. And the coterminal angle is this angle, this one over there. Over here, it was the same angle in the first quadrant. In the second quadrant, it's the angle which is from the other side. So that will be calculated by using 180 minus the t. Now, in the third quadrant, as this angle right here is in third quadrant. The coterminal angle is right here, this one. So that will be calculated by using t minus 180. And then you have the fourth quadrant. In the fourth quadrant, when you have the angle, the other angle which will have the same terminal is this one. So that is just this much away from 360. So you will use 360 minus the t to calculate that angle for your coterminal angles. Okay. Let me know if a question, thought, or wonder came to your mind while looking at the quadrants and while looking at these angles. Now there is an important thing which is coming up here, is known as reference angle. So they're saying coterminal and reference angle. Coterminal angles are two angles in the standard position that have same terminal side. An angle's reference angle is the size of the smallest acute angle T dash formed by the terminal side of the angle T and horizontal axis. Now, how to differentiate between the two and how to calculate the two. So we're gonna go down here. Given an angle greater than 360, find a coterminal angle between 0 and 360. So we will do subtract 360 from the given angle. If the result is still greater than 360, subtract again till the result is between 0 and 360. Resulting angle is coterminal angle with the original side. This is a three-step method that you can follow each time you're finding the coterminal angle. Now finding an angle, coterminal angle with the angle of measure greater than 360, and they have given an example of 800. So for 800, you subtract 360. If you subtract 360, it's 440, which is still higher than 360. So you minus another 360 and you get 80 degrees. This is the coterminal angle of 800-degree angle. And this is how it would look like. This is a beautiful picture to understand the coterminal angles. You see right here, the orange is showing you that one rotation is complete 360, the second rotation is complete 720, and then it was 800. So if this is second rotation, it's 720. We know 720 plus 80 will make it 800. So that measure is 800. Okay. And that is your coterminal angle for this angle. Okay. Now, scrolling forward to the next thing. So finding an angle coterminal with an angle measured less than 0 degree, meaning a negative angle, like you have negative 45 degree, finding a positive coterminal angle. So how we do that? This time we add 360 and we get 315 as our value. So as you see right here is 45 degrees. And when you do this, 45 degrees, you may think, okay, 45 degrees downward this way. Then from this line, this will be terminal from the original. What is the rest of the angle? 315, you can do that way also, or you can simply add 360 in there. If any question comes to your mind, feel free to ask. And we did length of the arc formula before as well. S is equal to r theta. So here are some examples to find that. An area of a sector, pi r square, is given as the area of the circle. And this is the formula that we use for the sector. And to derive that, we divide by 2 pi. 1/2 theta r square is the formula for that, for the area of a sector. Now taking us towards the linear speed and angular speed. Like speed is denoted with the symbol v, which is called velocity. And whenever they say the word angular, that same speed formula is written with the um, symbol looking like W, but it's read as omega equal to theta, the angle, over the time t. Okay. And then using this formula along with S is equal to R theta, if in place of theta you fill omega t, S will become R omega t. So that will be used in certain questions in the exercise as well. Angular and linear speed formulas one more time. W is equal to theta over t, V is equal to speed is equal to distance over time. So S over T is the formula for that. And then taking us down to your exercise problems. I hope my screen is visible for the problems now. And in this one, what we are saying here is convert 20 pi to degrees. So if you want to convert 20 pi to degrees, all you got to do is 20, fill pi as 180, and you multiply the 2. 18 times 2 is 36, and then there are 2, 3600 over there as the value for this one. Then negative 329 to the radians. So that's opposite of that. You will do negative 329 multiply with pi over 180. Then you can reduce if it reduces to the lower numbers, and that will give you the radians for this problem. 329 converted to radians as negative 329 over 180 pi. Your question 2 is saying find an angle between 0 and 360 that is coterminal with the given angle. So we begin by taking the number 470 as it's higher than 360. We subtract 360 from that. When we subtract, we get oops, I did write something else here. So 478 take away 360 is giving us 118 degree, 118, which is between 0 and 360. Then negative angle. For the negative angle to find the coterminal, so if you have negative 10, you will add 360 degrees to that, which is 350 degrees for this one. So 350 degrees as coterminal to negative angle. Then over here at 987, you take negative 987, you add 360. When you do that, you're going to have negative 627. And then you add another 360. And when you add that, you will have 267. And one more time, you're going to add 360. And now when you do that, you will have 107 as the value of this one. So 107 No, they're showing 93 degrees. I did something here. So 987 take away 360 in this one. Let's double check on the calculator. We can draw also on this one. So this part I'm going to erase here. I'm going to show you the coterminal angle from there. Yeah, it's 93 degrees. So when I did 360, I added to 987. 360 minus 987 is negative. This is negative 627. Then I was supposed to add another 360. And then when I do that, I get negative 267. And then I add another 360. And that would give me 93 degrees. And that 93 is should be the answer here for that one. Let me know if a question, thought, wonder comes to your mind for coterminal angles. So here is 8,569. So a big angle, 8,569. So first thing, I'm going to subtract 360 from there. When I subtract that, I am going to have 8,209. Then I'm going to subtract another 360. I'm going to keep subtracting 360 until I get the answer between 0 and 360. So when I subtract this time, it's going to be 7,849. Now again, I subtract 360. And when I do this subtraction now, I get 7,489. So I will still continue. So I have 7,489 minus 360 I would do. And when I do that, I have 7,129. I'm going to write it here now. I don't have space there. So 7,129, take away 360 one more time. That is 6,769. And you subtract again 360. Which would give you 6,409. 6,409 minus 360 would give me 6,049. So from here I got 6,049. Then I would minus again 360. I will reach at 5,689. And I will continue that way until I reach to the number between 0 and 360. So I'm leaving it right here and showing you the answer that it would be 289. It's going to take several other 360 to be taken out of the way. And then you come back to your answer of 289. Okay, so that was little story of your coterminal angles. And we go further with question 3. which says convert this angle from radian to degrees. So we simply say negative 7 pi over 4. To convert it to degrees, fill the pi value as 180. When you do that, you can reduce 180 over 4. They both are divisible with 4. So this would be 45 here. And then you multiply 7 with the 45. It's negative 315 degrees. Negative 315 degrees. Okay. Similarly, we have question 4 for each of the falling angle. Find the radian measure of the angle with the given degree measure. You can enter pi in your answer. So here we are given degrees. We can write it as radian. So we take 260, multiply it with pi over 180. When we do that, we can reduce 260 over 180 and then write pi with that. The 0 will cancel. 26 over 18. And here is a pi. They both are divisible with 2. So you're going to have 26 divided by 2 as 13. 18 divided by 2 as 9. So this answer would be 13 over 9 pi, which they have written as decimals. You can do the decimal answer also. Fill the value of pi in the calculator and you will have 4.537. Same way, 240, you will take multiply with pi over 180 and get the answer. Negative 360 simply means opposite of the rotation. So it's clockwise, negative 2 pi. And then calculate 300 degree, multiply with pi over 180, and then calculate 180, multiply with pi over 180. So it will be just pi, which is 3.14159 on the calculator always. So from there, taking us forward to question 5. The angle between 0 and 360 and is coterminal with the standard position angle measuring 1986 is. So we are basically finding coterminal angle with 1986. So I would subtract 360 as a first thing. And when you do that, 1986 take away 360, it would be 1626. You subtract 360 again, and you get 1266. Subtract 360 again, you will get 906. Subtract 360 again, you get 546. And then from 546, you subtract 360 one more time. And that's 186. So that 186 will be the answer right here for the degrees. For question number 5. Here in question 6, it says convert 340 degrees to radians. So for that, 340 degrees to radians, you will take 340, multiply with pi over 180. So 340 multiply with pi over 180, which is 340 pi over 180. Now try to reduce this 340 over 18. You will have 34 over 18 pi. They both are divisible with 2. So I will divide 34 with 2, which is 17, and 18 with 2, which is 9. So 17 over 9 pi radians, or you can also write it in the decimals. 17 pi over 9 radians for this one. Then convert pi over 18 to degrees, meaning simply I would fill pi as 180 over 18, which is 10. So this will be 10 degrees. Taking us forward in question 7. Sector of a circle has a central angle of 30 degrees. Find the area of the sector if the radius of the circle is 15. So we are given the radius, we are given the angle, and we are finding the area of the sector. If you remember, I shared with you the area of the sector formula from the book when I shared with you, showing an angle and all that. It was 1/2 theta r square that we will be using here. 1/2 theta r square. And theta is given to us 30 degrees and radius is 15. So 1/2 times 30 times 15 whole square. 30 divided by 2 is 15. So you basically have 15 times 15 squared. We calculate that. And I get a big giant number in the calculation as for this one, I'm getting 15, I don't know, I'm getting 15 to the third power as 3,375. Let me double check on the formula. Area is 1/2 theta r square, which we used, 1/2 theta r square. 30 degrees is the angle. And radius is 15, and they're showing the answer as 58.9. My answer is coming up as 15 times 15 times 15, 3375. So let's double check on this one. Maybe something that I didn't put right in there. The area of a sector. So they convert the degrees to radians. So that's why they are getting the answer as in the decimals. So I got to write that 30 degrees as pi over 6 before moving on. So 30 degrees I'm going to do right here as pi over pi over 6. 30 degrees when you convert to radians is 30 times pi over 180. And 30 and 180 cancel with each other. That's pi over 6. That's where that pi over 6 is coming from. Then when I go to the next step, I have that pi, which is 3.14 is the pi value divided by 12, and here is 15 squared. So now we run the calculation on the calculator. 3.14 times 15 to the power 2 divided by 12. So I do get 58.9048 as the answer to this one now. Let me know if a question, thought, or wonder occurred. Question 8 says, convert the angle 360 degrees to radians. So we simply take here 360 degrees and convert this angle to radians means multiply by pi over 180. 360 and 180 cancel with each other and give you 20 here. No, 2 here. 180 times 2 is 360. So we get 2 here, and that is 2 pi. Or you can simply think when you complete a rotation, that is 2 pi. 360 degree as a radians is 2 pi. Now we go further from here to the next thing. Question number 9 is saying, write an expression describing all the angles that are coterminal with 72. Please use the label K in your answer. Give your answer in degrees. Do not include a degree symbol in your answer. So what does it mean by K, and what does it mean by all the angles here, so which are coterminal? So what we got to tell here is simply that, okay, this is your coordinate system. Here somewhere 72-degree angle. Coterminal are all the angles which are coming from this side and are having this side as terminal side. They are in the rotation of 360, and there are k possible things that are doable from there, because when we do this one rotation, we can also do another rotation and go again reach to that, and another rotation go reach to that. So 72 and k means several time you can be reaching to that position. 360 plus 72k. That will be the possible answer for this one. So 360k plus 72. Then question 10, I think I was writing the other way. I was saying 72k. It's 360k plus 72. But the meaning of me saying was the same, that we can come over and over to that same location because it's a circle of 360. We are taking the rotations. 72 plus 360k. Then number 10 says, convert the angle 2 pi over 3 from radians to degrees. When we do that, we simply fill the pi as 180 and we calculate. This is 360 divided by 3, which is 120 degrees as your answer. 120 degrees. Then we go further to the second section of this chapter, which is also an extension of the angles. So I'm going to take us to the book first and right here to section 5.2. The unit circle, the sine, and the cosine. We did talk about quadrants, so you know a little bit of the information already, and finding function values for the sine and cosine. So this picture, this diagram is beautiful to understand all the things right here. So this way, where the orange line is, where I'm drawing my purple line right now, the x-axis line, that is called the cos. And this way, the orange line, the line parallel to the y-axis, is called sine angle. So for this angle, it could be theta, or it could be alpha, or it could be t. The cos t is this way and sine t is this way. So the x value right here would always be the cos, and the y value would always be the sine here. So if you take a look, this is a right angle triangle, and this is a unit circle, we call it, because this radius is 1 unit marked here. Then we can use that analogy that cos square t plus sine square t is equal to 1 from the trigonometry here for this right angle triangle. So then x square, if this is x, this is y, we get here x square plus y square equal to 1. The Pythagorean identity applies here, and the three things are linking together, your Pythagorean, your trig, and this unit circle. So now taking us forward from here, we're gonna have different angle measures like 30, 45, 60, 90, and all that. And for those angle measures, we're gonna be finding the values of cos and sine. Now, one more thing, where is this coming from? The 1/2 and square root 3/2. And all those we're gonna be talking in this unit circle. So this is the thing I showed you, cos square t plus sine square t is equal to 1, or x square plus y square is equal to 1, Pythagorean identity. And we use those identities to solve for your quadrant 1. So quadrant 1, we use that special angles like 45 and 90, because three angles of a triangle are supposed to add up to 180 degrees. So they use that 45, 45, 90. So if it's sine 45 or cos 45, what would be the value? So if we are using sine 45, do you guys remember or know the SOHCAHTOA identities? I'm writing the word so, so, Tua. Do you know that? Are you guys familiar with SOHCAHTOA identities? Yes, no, kind of. It is like S stands for sine, O stands for opposite, H stands for hypotenuse, C stands for cos, A stands for adjacent, H stands for hypotenuse. For TOA, T stands for tangent, O stands for opposite, A stands for adjacent. So they're using special triangles here. So this is 45, 45, 90 triangle, and they're trying to say, okay, if it is sine, sine is sine is opposite over hypotenuse. So from this angle, opposite is y, hypotenuse is 1. So opposite is y, hypotenuse is 1, and it is sine of 45 degrees. Okay. Then sine of 45 degrees, we fill that in and we can find the y values. That's what they're talking here. One more thing that I am going to write here, which I didn't see in the book, is a trig table, which will be useful to you. So those values, I'm going to probably write somewhere where I see a lot of space, and I want to have the circle next to that. So this is that unit circle, and I'm going to make the trig table right here. So this is a trigonometry table I have my students usually keep in mind whenever they're working on unit circle and all that. And way of keeping this in mind is not very hard. So I will tell you what to do in there. I'm going to make 3 columns here, and then 30. Going to begin from 0, then 30, 45, 60, and 90. And to make the table for sine, cosine, and tangent, the way I do it is I just start writing from 0, 1, 2, 3, 4, and then you divide by 4 on each. Then you take a square root on all the values. Same way here, you're going to begin 4, 3, 2, 1, 0. Divide by 4 on each number. And then you take a square root. And then this 0 over 4 is basically 0. 1/4 under the square root means 1/2. Square root 2/4 means square root 2 over 2. Square root 3/4 means square root 3 over 2. 4 over 4 is 1. Under the square root, 1 is 1. Same way, this is 1. And this is square root 3 over 2. This is square root 2 over 2. This is 1/4. Square root will be 1/2. This is 0 right here. And tangent is a division of sine and cos. So when you divide 0 over 1, it's a 0. 1/2 with square root 3 over 2. So it's 1 over square root 3. And these two are same, so they divide up to 1. Square root 3 over 2 divided by 1/2 would give you square root 3. 1 over 0 is undefined. The tangent is sine over cos. That's what I did say in last few seconds, that I'm dividing the sine values with the cosine values. So that's where this one comes from. 1/2 sine cosine values. So the cosine value 1/2, sine value square root 3 over 2. Cosine value 1/2, sine value square root 3 over 2. So this angle is 60 degrees. I can tell by looking from my trig table that this angle is 60 degrees, because at 60 degrees, cos value is 1/2 and sine value is square root 3 over 2. Okay, so that's how this trig table will be useful, and probably I will repeat it one more time later whenever needed. But this is very useful for our lesson of today. And with that, I am going to take us forward, and I'm going to erase this table for right now. It's simple to draw. You don't have to memorize much. In the sine line, you have 0, 1, 2, 3, 4. Divide by 4, take a square root. In the cos line, 4, 3, 2, 1, 0. Divide by 4, take a square root. Tangent is sine over cos. That's all we do here to make the trig table. So now taking us forward to, I think that's what we will need to figure out the questions in the exercise. I'm going to take us to the exercise and see, as per the need, I will supply you more information on the unit circle. So taking us down to 5.2 and making it visible on your side as well, so you can see it on your end also. Okay, let me know if 5.2 became visible on your end. Thank you for confirming. Okay, now here again, I am going to draw the table to help you know what goes where, because we're going to need it for these questions as well. So here goes the table one more time. I will write it here because we're going to need it here. So that's the top line. Then we're going to have sine cosine and tangent. Sine, cosine, and tangent. And then we're going to have this way 0, 30, 45, 60, and 90. So let's say here is 0. Let's say here is 30. I can make this line a little bit more space here. 30, 45, 60, and 90. So now I'm going to write in there. So this is sine, cosine, tangent. This is 0, 30, 45, 60, and 90. And again, I write from 0, 1, 2, 3, 4. And I divide each number with 4 and take its square root. And then I will have 0 here, 1/2, square root 2 over 2, square root 3 over 2, and 1. If I start writing here from 4, 3, 2, 1, 0, divide them all with 4 and take a square root, I will get my second line. Square root. So this is 1. This is square root 3 over 2. This is square root 2 over 2. This is 1/2. This is 0. Tangent is a division of sine with cosine. So 0 over 1 give me 0. This would give me 1 over square root 3. This is 1. Here is square root 3. Here is undefined. Okay. Now sine pi over 4. Pi over 4 means 45 degrees. And I can write the radians here also. 30 means pi over 6 radians. 45 means pi over 4. 60 means pi over 3. 90 means pi over 2. Okay, so we are finding sine 45 degrees or sine pi over 4, which is square root 2 over 2. So that would be square root 2 over 2 right here. And then cosine of 45 is also square root 2 over 2. That's how you get these answers. Then right here is negative pi over 6. Negative pi over 6 would be, the pi over 6 is 30 degrees. So it's 30 degrees down here. Now I will explain to you a couple more things regarding your unit circle and the repetitive pattern of the unit circle. So let's say here is my x-axis, and let's erase this line. And let's say here is y-axis. And let's say here is the unit circle. Let's draw it. I don't know, it's not coming very neat. So I have to do something else. I will do it with the free hand. So here is my unit circle. Okay. Didn't come out very neat though, but it is what it is. So if it's 45 degrees here in the middle, it's going to be also 45 degrees here. That same. Whatever numbers are here, those same numbers will be here, but this is the fourth quadrant now. This is quad 1, 2, 3, and 4. In quadrant 4, this side is positive, this y is positive. In quadrant 2, this side is negative, the upper side is positive. In quadrant 3, they both are negative. Quadrant 4, x is positive, y is negative. So what does that mean to us? So suppose here is an angle of um, 60 degrees, 30 degrees, which we are looking for. So 30 degrees we are currently looking for. So 30 is here. And 30, cos 30 value is 1, and sine 30 value, cos 30 value is square root 3 over 2, sine 30 value is 1/2. So I am going to write those two here. That cos 30 value is square root 3 over 2, square root 3 over 2, and sine 30 value is 1/2. So I'm just using the one that was sitting there from previously written quadrants. So that, okay. And when they're asking me question like negative pi over 6, that means I am having 60-degree angle, 30-degree angle down here. So those same quadrants, the same numbers will be here, but now in this quadrant, the y value will be negative. So square root 3 over 2 will be square root 3 over 2, and the 1/2 will become negative. So that 1/2 will be negative 1/2. And in the unit circle, first value is always the cos value. Second value is always the sine value. So my sine will be negative 1/2 for the negative pi over 6. And my cos will be still square root 3 over 2. That would be the answer to this problem, number 2. Negative 1/2 and square root 3 over 2. Let me know if a question, thought, or wonder came to your mind. All right, so taking us forward, I am gonna erase this one, this one, this one. Keep the table up there because we're gonna need table over and over in this exercise. So keeping that table there still. And going forward here to the next. It is saying cos theta is equal to 1/7 and theta is in the first quadrant. Find the exact value of sine theta. So if that's the scenario and it's in the first quadrant, so cos theta got to be somewhere in the first quadrant. We don't know where that is, but we got to figure it out. So let's suppose it's here somewhere, or here somewhere, or here somewhere, or here somewhere. I don't know where that is, but it is somewhere there. And we can make a triangle here. And we can say, okay, this side is cos, this side is sine, and this is the angle theta. And this is a unit circle. So we have that formula, which is cos squared theta plus sine squared theta is equal to 1. Cos theta is given to us as 1/7, so we will fill that in 1/7 square. Sine theta, we're going to find out as the exact value. So we have 1 over 49 from 1/7 square plus sine square theta is equal to 1. Then I erase this to make some space, and I write here sine square theta is equal to 1 minus 1 over 49. So that will give me 48 over 49. Then I take a square root. So I'm going to say this was sine square theta. And that means sine theta will be square root of 48 and divided by 7. So if I take square root on both sides, here and here now, it would be square root of 48. Square root 48 is 16 times 3, and square root 49 is 7. So it will be 4 square root 3, 4 square root 3 over 7 in the answer, because it's asking exact and no decimal. 4 square root 3 over 7 would be the answer for the sine value. That was your third question. And as we move forward, I would again need to erase. I'm going to erase this one. I don't want to erase the table. I still want to have that. I will erase this one also. I will take us forward to the next thing. Okay, moving forward. We have question number 4. Question number 4 is saying, find an angle theta with theta between 0 and 360 that has the same sine value as 200 degrees. Cosine function value as 200 degrees. So we are finding an angle between the unit circle starting from 0 going up to 360, and where sine function value as 200 degrees and cosine function values as 200 degrees. And we are finding that particular angle. Okay. So what I'm going to do here is I'm going to do a little drawing to help you understand what this question is telling us or asking us. So this is your y-axis. Here is your x-axis. And here we draw a unit circle. So let's try to draw here. That's your unit circle. So if we take this as initial side, start drawing and go this way. Right here is 90, 180, and somewhere down here is 200 degrees. 200 degrees right here. And cosine 200 would be same as that. Now they're asking what is the other sine function which has same value as that value. Okay. So that would be if I go from the other side, it would be little less than little less than 108 degrees. So if I am thinking of going from, let's say, from here, if I start and I go this way, I wanted to reach this place. This full is going to be 180. And coming from that side, this was 200. So which is 180 and 20 more than that. And this way it is 20 less than that. So that would be um, giving the sine value as 200 degrees. But I wanted to write some math also for you to know more than what am I trying to draw. And I wanted to show you a little other picture. Sine 300, sine of 340 would make it, and cos of 160 would make it. I wanted to show you the math also. So for math part, I'm going to show you a worked example so you can understand what's going on. You look at my example that I'm trying to share from another screen that would bring that picture thing all together for us. So here you see in the diagram, they are also determining the same thing, like whatever is this location, parallel to that, that same location of the y, sine theta and cos theta angles. So like in our question, we have sine of 200 and cosine of 200. They have sine of 310 and cosine of 310. So 310 is somewhere here, sine of 310 and cosine of 310. Exact same measure of that would be, the y value would be here, which is sine value. And this was the x positive, so that same measure would be in the first quadrant for the cosine value. So I'm going to move this a bit forward to show you a little more on that example. So this x, because this x side is positive, so this is positive down here, so that will be positive here. This was 310 all the way down here, but how much will be this much right here? So 310 is 50 degrees away from 60, 360. That means this angle is 50 degrees. Then the y location will be same in this quadrant right here. And how far away is that? This was 310 right here. And this one is 180. So from 180 um, downward, 310 on this side is 50 away. So 50 away from 180 on this side. So 180 plus 50 um, would give you 180 plus 20 is 200, and 230 is the location of the sine there. That's what we are seeing and talking in this question also, which was part of our problem. So if you see right here in our question, which is 200 and 200 degrees. So I'm going to mark the x's that I was marking before to make sense of the things all together. So right here, and then we draw the angle using, let's say, an arrow from here, and we are going 200. So 200 is over here. And then I mark my unit circle around it. So let's say I'm marking just a random unit circle this way. Didn't do a very neat unit circle, but that's a unit circle. So this location has x value negative, negative x because of this side is negative x side, and downward is y negative. So both the values of sine and cosine are negative here, sine 200 and cosine 200. And if you remember from the unit circle, every coordinate over there has cosine first and then sine later. And they both are negative here. So that means negative x and negative y. Where else it would be present? Then negative x and negative y, exactly the same down here in this fourth quadrant. So we're gonna do another arrow from here, and we're gonna do, okay, from here it's gonna be exactly as much deeper the other was, the same here. But the x on this side is positive. We want the x negative, we want the y also negative. So x negative is on this side. That same exact location would be right here on this side for the x value. And this number is 180 when you reach the flat line. So 180 and this was 200. So 20 degree below that. This is 20 degree above that. So for this one, the x value is cos value. So this will be cos of 20 less than 180 is 160. So cos angle is going to be 160. And for the y value, it's going to be 20 below the 360. So that's going to be sine of 340 degrees. So they're saying what would be the same location as sine 200? And I'm going to say 340 here. 340 here. And they're saying what is the same value as cosine value? So I am going to say 160 for the cosine. Those will be the two answers that will go right here in these two blanks, 340 and 160 degrees. Okay. Any question, wonder came to your mind, feel free to let me know. I am going to erase this one. Now and take us forward. So this is saying sine theta is negative 2/7 and theta is in the third quadrant. Find the cosine theta. Enter your answer as a reduced radical. Enter square root 12 as 2 square root 3. Okay. So firstly, we draw the diagram. And for drawing the diagram, we have this one as y-axis. And we have this one as x-axis. This is your x-axis. That's your y-axis. And for the quadrants, this is the first quadrant, second and third. So we are coming all the way down here in this third quadrant. Somewhere here, the sine value, as you know, the sine is the y, the cos is the x. So the sine is negative 2/7. Cos we are finding. Okay. So for this one, drawing the unit circle around it, drawing a unit circle around this one. It's a freehand drawing, so the circle is not very round. But at this point, somewhere, the sine theta value is negative 2/7. And we're supposed to find the cos theta value. Now, if you remember that analogy that cos squared theta plus sine squared theta is equal to 1, because this is going to make a right angle triangle and it's a unit circle. So we're going to say cos squared theta plus sine squared theta is equal to 1. And sine theta is given to us. Sine theta is negative 2/7. So square of that will be 4 over 49 equal to 1. Then cos square theta is equal to 1 minus 4 over 49, which would give us 49 take away 4, 45 over 49. Then you take a square root. So your cos theta is equal to square root of 45 over 49. And that would be square root of 9, 5, 9 times 5, 45, and over 7. So the answer will be 3 square root of 5 over 7 for this one. 3 square root of 5 over 7. And the negative sign, because it was in the quadrant down here where x and y both are negative. So you will put automatically negative sign in front of the answer. Negative 3 square root 5 over 7. About to erase this, take you forward to the next problem. The next one is question 6. It says find the coordinates of a point on a circle with radius 20 corresponding to an angle of 190 degrees. So this is not the unit circle, but this is a circle with a radius of 20 degrees and radius of 20 degrees, and it has an angle of 190 degrees. So whatever angle is given there, we will suppose the x and y value and then find the sine, cosine angles of that, that picture from there. So I am going to draw first for you to understand that what we are talking in this one. So let's say I draw this time the unit circle first. So I will have my unit circle. Then I am gonna do the x-axis and y-axis. So let's say this is x-axis. And let's suppose here is your y-axis. And we are having an angle of 190 degrees. So 190 would be all the way, if I start from here, this is 90, 180, 10 degree more than that, right here. Okay. And we're gonna mark a couple things here. We're gonna say, okay, let's make a triangle here. And if this is the angle theta, the angle is right here, angle theta for this one. This side is the x side. This side is the y side. That is the angle. And from using your SOHCAHTOA rules, this would be the radius, the hypotenuse, and cos theta. SOHCAHTOA, the cos is adjacent over hypotenuse. So cos theta will be x over r from this angle. From this angle, looking from this side, this is opposite, this is adjacent, this is the hypotenuse. So SOHCAHTOA, the cos is adjacent over hypotenuse. So x over r, and sine theta is equal to y over r. Sine theta is equal to y over r. So that would give us two things. One thing, it's going to give us x is equal to r cos theta. So we're going to have x is equal to r cos theta. Theta I have to write with the pen. And y is equal to r sine theta. That's what we're going to have. R sine theta. Now, in this question, we are given the radius 20, which is r. We are given the angle 190 degrees. We can fill both of those in and we can calculate the answers. So r cos 190 will be the x value, and r sine 190 will be the sine values. And if you feed them to the calculator, you will get the decimal numbers like this 19 point blah, blah, blah. And they both will be negative because you are in the third quadrant, which has x and y values negative for that. That was number 6. And if anything comes as a question, feel free to send that question my way, either unmute yourself or chat. Number 7 says P point is on the unit circle if the y coordinate of the point is 2/5 and P is in the quadrant 2, then find the x coordinate. Okay, so we draw here again. Drawing is gonna be needed. So I'm firstly drawing unit circle again. That's my unit circle, suppose. And here goes my x-axis. Not a good location for that. So I'm gonna do the x-axis right here. And I'm gonna do the y-axis right here. And I'm gonna do, it says y coordinate of the point is 2/5 and it's in the second quadrant. Second quadrant means somewhere here. This is the second quadrant, okay? So in this quadrant, second quadrant, you have a point P somewhere. So let's mark that P here. That point is P. Cos, the x coordinate is cos, that's missing. The y coordinate is sine, which is known, and that is 2/5. So I don't know what the angle is, where the location of the point is, but all I know is that formula x is equal to r cos theta, y is equal to r sine theta. And the second thing I know is sine theta is given to me 2/5. Sine theta is given to me 2/5. We can use the formula sine square theta plus cos square theta to find the x coordinate, which is the cos value. So I'm going to do that here. Cos square theta plus sine square theta is equal to 1 because it's a unit circle. So cos square theta is the x coordinate, which is unknown to me. Sine square theta is 2/5, which is squared equal to 1. So I'm going to have cos square theta is plus with 4/25 equal to 1. Moving 4/25 to right side would give me cos square theta is equal to 1 minus 4/25, which is 21/25. And if we take square root of that, it will be square root of 21 divided by 5. Square root of 21 divided by 5, and then you turn it into the decimals, negative 0.916. You can check that on the calculators. I'm also double checking on the calculators to make sure that I get the same decimal. And it will be negative in the third quadrant. So that was number 7. And if any question came up, let me know. So with that, we go to number 8. This angle is given, then we are finding sine 5 pi over 3 and cosine 5 pi over 3. And it says give exact values, no decimal answers for this one. So for this angle, all we got to do is we can convert it into degrees if we want to see the degrees, and then we can write the answer by using the trig table, which we made earlier. We can use the unit circle also. If we are using the unit circle, we go this way. So it's 5 pi over 3. I will show you where 5 pi over 3 is in your unit circle. Here is the unit circle with the information that we shared in your exercise. I'm going to show that to you, the complete unit circle picture, which I shared before. So right here, this one. The question was saying 5 pi over 3, which is this one, 5 pi over 3. Question is asking the cos value and the sine value exactly. So the cos is 1/2 and the sine is negative 3 over 2. That's all we're going to say by reading the unit circle and writing the answer here. Negative square root 3 over 2 and 1/2. That comes from the unit circle. Number 9 is saying without using a calculator, compute the sine and cosine of 240 degrees by using the reference angle. What is a reference angle for 240 degrees in your unit circle? So reference angle is the angle at the same location in the other quadrant of your unit circle. Like your unit circle will complete at 360 degree, and 360, 240 is 60 degrees away from 360. 60 degrees away from 300. 360 take away 240 would be 120. And you're trying to find the reference angle. So you got to think like this. Either you look at the unit circle pretty quick, I can show you from there, or we draw it here. I think the unit circle will be faster for me to show. So I'm going to show you the unit circle picture right here. So this is 240 right here. This one, which is the third line down here. The reference angle to that will be the same location in the first. So if you go right here, as you go from 180, how down you went? You went 30, you went 45, you went 60. Like you go in the first one, 30, 45, 60. So this is 30, 45, 60. 240 is 60 degrees away from that. So that is the reference angle for that one. So we will tell 60 degrees as our answer to this one. Reference angle is 60 degrees. And in what quadrant it was? Remember, there are 4 quadrants, 1, 2, 3, and 4, and it was in the third quadrant. Then sine of 240 and cos of 240. 240, cos value is negative 1/2, sine value is negative 3 over 2. So those two values should be filled here using the unit circle. Then down here, number 10, without using a calculator, compute the sine and cosine of 5 pi over 3 by using the reference angle. So again, what is the reference angle? Firstly, reference angle I'm going to show you for 5 pi over 3 this time. 5 pi over 3 is this one right here. So this one is your 5 pi over 3. So if you go this way, that's what you're referring to, that how down you are from that x-axis. That is your reference angle for 5 pi over 3, like 30, 45, and then you go to the 60. And in radians, it was, if you look at the radian location, this should be pi over 3 because it's 60 degrees down from 300. So pi over 3 radians. In what quadrant it was? Fourth. Sine 5 pi over 3 and cos 5 pi over 3. Cos value is 1/2, sine value is negative 3 over 2. So 1 negative 3 over 2 for sine and 1/2 for the cos. We read the unit circle and we fill the value in there. We don't do any calculation or anything there. Now we go to the next one, number 11. It says for the information given, find the quadrant in which the terminal point determined by T lies. Input 1, 2, 3, or 4. Sine less than 0, cosine less than 0, meaning sine and cosine both are negative. If you remember, and I will show you the picture again, the sine negative, cosine negative, x negative, y negative. That happen only in quadrant 3. If you look at the values, both the values are negative. So that is quadrant 3. Then sine positive, cosine negative. Sine positive, cosine negative. Cosine value is the first value and sine value is the second value. Sine is y. So they're saying sine negative, cosine positive. So cosine positive, no, they're saying sine positive, cosine negative. Sine positive, sine positive. Sine is the y value positive, cosine negative. So that's going to happen in this quadrant. And that is your quadrant number 2. Then sine positive, cosine positive. They both are positive in the first quadrant. X is positive, Y is positive. So both the values are positive. So that is in quadrant 1. Sine negative, cosine positive. Sine means Y, cosine means X. And the question is saying sine negative, cosine positive. Cosine positive this way, sine negative this way. So that is this quadrant, quadrant 4. Then we go to the next one. I believe this is the last one. Find the angle theta that has the same sine as 40 degrees and same cosine as 40 degrees. So I'm going to show you the unit circle again here. So sine 40 and cosine 40 is right here in this quadrant. They both are positive. So cosine will stay positive in the fourth quadrant also. So 40 degrees below that will be, if it's 40 degree above, 40 below 360 will be 320 for the cosine. And if it was sine 40, sine positive, sine is the y value. That's going to stay positive in the second quadrant. So in the second quadrant, 40 above this, that will be 140 degrees for the sine. 40 degrees above 180. So those two numbers should go in there, 320 and 140. 140, 320. Okay. So that was number 12. Let me know if anything as a wonder or question occurred to your mind that you want me to go over. Other than that, we are set for tonight. We have both the exercises taken care, the first one or the second one, and they're open and available to you. So you guys take care of those exercises. Get back to me in the next meeting, which will be on Tuesday, the same time, live Zoom session at 6 o'clock. I will send you the Zoom link again. We'll meet up there. Good night, Jonathan. Any questions, Vladimir, before we depart? Have a good night.